Good afternoon, everybody. Uh, the current session is quite relevant with the today's scenario, advancements in clean energy research and development. I am UK Verma, Executive Director, Technical Engineers India Limited, along with my co-chair, Mr. Atul Choudhari from the Tata Consulting Engineering. Welcome you all to this engaging session. Well, the topic is very much relevant in terms of that while we are going for the energy storage, energy optimization, it has to be carbon neutral. Because to achieve the aim of net zero as per the COP directive, we need to eliminate the C component of that hydrocarbon molecule. So we have all the four presentations, engaging presentations lined up today. Without wasting any time, I'll ask my co-chair to start the session and invite the speakers one by one.
Yeah, good afternoon all. Let's start with this session. Clean energy transition under development. Lot of experimental things have been done and lot of ecosystem is under being developed. So today's session we will talk about the modern technologies and new upcoming areas where we look forward to implement it in near future. So I invite our first speaker, Mr. Malay Pramanik. He comes from HPCL R&D to come on the stage and present his paper, please.
Good afternoon all, and I would like to thank to IUW for accepting our paper and give us opportunity to present our work in this prestigious forum. So the topic of my presentation is development of novel energy storage devices from refinery byproducts for high performance e-mobility applications. So I'll directly go to the about the innovation. What is the innovations about all these things? Here we have developed a high quality of carbon materials from the refinery byproduct, which is known as pet coke, petroleum coke basically. And this pet coke has been activated by conventional chemical activation process, and then we have made very small cell where we can check the performance of these pet cokes, and then it has been scaled up to 1000 times, and which has made the India's first 1200 farad supercapacitor, which is indigenously made. Because supercapacitor, just few things about supercapacitor I like to tell, that it can be charged very quickly, because although its energy density is less compared to conventional batteries, but it can be charged very quickly. Within 1 to 2 minutes it can be charged. And from these carbon based materials we have made the supercapacitor, and from there we have made the supercapacitor bank as well for the e-mobility applications. And we have made one bank. You can see this is called the supercapacitor pack on the left side of the image in the bottom part, and which has been used for e-bicycles. And the main important point of this device is that it can be charged within 3 minutes only. So what is the use of different kinds of the supercapacitors? Can be used majorly in automotive, medical and health sector, also power electronics, space technology, and solar harvesting and storage applications as well. It can be used. So what is the innovations here and technical aspects of the product? So basically petroleum coke is a kind of is a carbon materials which emits 11% more greenhouse gases than the coal when it is being burned basically. And in India, where we are energy our criticality of the energy we all understand. And that's why the always this pet coke has been used as the alternate of your coal, for particularly for aluminum as well as cement industry. So this is a kind of byproduct, and it is also emitting lots of greenhouse gases when it is burning instead of coal. So our effort was to make this pet coke to a valuable carbon materials which can be used for green energy storage applications. So from there we have made this these energy storage devices which can be charged within 3 minutes, and it can the most important part of this kind of storage device, it can be charged and discharged more than 20,000 cycles. And as the carbon content of your or pet coke materials is more compared to conventional carbon materials from where the supercapacitor is being made. Basically this is called the coconut shell, where the carbon content is only 30 to 40%. Here your carbon content is around more than 70%. So in terms of carbon economy, this is better compared to the commercially available supercapacitor which is in the market in present days. I will slightly go to how the process has been carried out. This is the simple diagrams. We have get the petroleum coke from our refinery, and then it has been cleaned with water. It's very simple process, around 20 to 24 hours. Then we have added the activating agent, and then it has been heated up in inert atmosphere, and then it has been washed with water. The one of the major important point here that generally washing step in this chemical activation process is very much high, but we are able to reduce the amount of water more than 3 times compared to conventional chemical activation process. And from there we are getting these porous carbon materials. These materials has been characterized by different modern techniques like XRD, XPS, and surface reanalysis. Then we have carried out the electrochemical analysis, and finally we have made the big supercapacitor bank for the energy storage applications. This is the materials property, which is the most important thing for making the energy storage get great carbon materials, because carbon is everywhere. But how to make any carbon to the valuable carbon materials which can be used for energy storage purpose? Here the important thing is that if you see that your graphene like structure is there inside these carbon materials after activation. This is the one of the most important thing to increase your electronic conductivity as well as ionic conductivity of the materials which is required for your energy storage applications. Apart from that, the surface area of the materials is also very high. It is more than 2300 meter squares per gram. And along with these things, the pore size distribution, because surface area is there, that means there are lots of pores will be there in the materials. The pore size distribution is also very important. Here we can tune the pore diameter and the micropore to mesopores dimensions by changing the synthesis conditions. Along with these things, from this Raman spectroscopy, from the image D, we can see that ID by Ig ratio, which is very common for measuring the graphitization of any carbon material, it is less than 1, which indicates that significant amount of graphitic like carbons is present in the material. Then after that we have carried out the scaling up process for cylindrical supercapacitor. This is called the cyclic voltammetry for the EDLC, the electrical double layer capacitor. We achieve the specific capacities around 121 farad per gram, and which I would like to mention that it is more than 25% higher compared to commercially available carbon material, which is YP50, which is being sold. And these materials can give the 27% more specific capacity in the same experimental conditions. And these materials have the excellent cycle life of more than 20,000 charging and discharging cycles, having more than 90% specific capacity retention. Then from there we have scaled it up to for making the cylindrical type supercapacitors, and there are different processes are there from materials, which this carbon materials is basically kind of powder, black powder we will get. From the black powder we have to transfer to the electrode materials. So there is several processes are there like mixing of the components, and then coating, calendaring, slitting, winding, flattering, laser welding, feeding, grooving, sealing, electrolyte filling, and final device. that in every stage there are lots of process parameters has to be optimized to get your best performance from your supercapacitor. And finally we are able to get around 1200 farad supercapacitor. and and it is in terms of the cost, energy saving and GHG emission, we can tell that this is much more superior compared to commercially available supercapacitor. Generally, there are few companies are there who is supplying the supercapacitor. We have compared our results with the commercially available those supercapacitor provider, and it's in terms of energy density and in terms of cycle life, it is better compared to those things. After that, we have made a supercapacitor bank which is made of 16 supercapacitors, and can give around 36 volt. And we have integrated that supercapacitor bank with one bicycle, and that has been demonstrated for it can run in 3 kilometer in per charging with the maximum speed of 25 kilometer per hour, and it can be charged in within 3 minutes only. Means very quickly we can charge these kind of energy storage devices. Apart from these things, I would like to tell that the GHG emission, which greenhouse emission, can be reduced significantly by this technology, because already I have just touched up that conventional supercapacitor is being made from the coconut cells. Coconut cells carbon content is only 25 to 30%, and the remaining rest is only the oils are there. But here, as it is a rich source of carbon, that during this activation process, the carbon dioxide emission is very much less compared to your conventional coconut cell based supercapacitor materials. And in terms of energy savings, this process is a only single stage process, because if you want to make the energy storage grade carbon from the coconut cell, then first you have to carbonize. Then after carbonization there is one more step, this is called activation. So those are two stage processes, but here instead of two stage process can be combined in only one stage process. No carbonization process is required here, only activation process is enough to get the energy storage grade or supercapacitor grade carbon materials. So I would like to conclude my presentations by saying that this is a kind of first initiatives where the petroleum coke, which is the waste product basically, or generally being burned in with when the coal is not available in this case, or in the replacement of coal, but due to the presence of more amount of carbon, the GHG emission is higher in this case. We have tried to develop those materials which can be used for the different kind of green energy storage devices. And these materials are very much locally sourced, because we know we all have these refineries can produce loads of different kinds of coke. Here we have taken petroleum coke, we have also worked on different types of delayed coke and different types of materials as well, and this can substantially reduce the cost and energy for the consumer. And here on, and the another important thing is that if you see the different kinds of batteries, there are lots of other minerals are required like lithium, cobalt, manganese. Those are scarce elements, and particularly lithium and cobalt, and it has to be harvested from different parts. Few are available in India, few not available in India. But these energy storage devices is completely carbon based. This carbon based energy storage device can give revolution the energy storage market in near future, I believe. Yeah, thank you. If anyone has any questions, I will be happy to give the answers.
Yeah.
Okay.
Thanks, Malay. First of all, thank you so very much for finishing your presentation well in time. For the audience, we'll have the question answer session at the end. And now I'll ask my co-chair to kindly invite the next speaker.
Yeah, Mr. Nikhil.
Good afternoon, everyone. It's a pleasure to be in front of such a wonderful crowd, sharing the same vision to safeguard our environment. Uh, Thank you all. So I want to present on the topic development of new apparatus for measurement of corrosion resistance property of EV fluid under the influence of electric current. The whole presentation will move as I will discuss on the EV market, followed by EV powertrain. Then I will touch upon the EV fluid development challenges. Then I will introduce you to a new apparatus which we have developed in design, followed by one EV fluid formulation studies, and then the conclusion part. In the EV market, you will observe that the major component of the plug-in hybrid electric vehicles and the battery electric vehicles are dominating majorly in China and Europe, followed by USA. All these three countries are contributing somewhere around 90% of EV market, more than 90%. And the remaining countries are contributing less than that. They're catching up, but there is a long way to go. In the EVs, we mainly divided in three parts. First is the hybrid electric vehicles. Second is plug-in hybrid electric vehicles. And the third one, battery electric vehicles. These classifications are majorly based on the source of external energy. In the first one, we have hybrid where the power source is again the fossil fuel. In the plug-in hybrids, we have both the power source as fossil fuel as well as electric current. But in battery electric vehicles, the major source of external power is electric current. In this part, we majorly concentrating on the plug-in hybrids and the battery electric vehicles, where the recent trends is mainly the integration of what we say the motor, inverter, and the gearboxes. So because of these integration, future integrations, the formulators like us are facing a lot of challenges in terms of heat transfer properties, frictional properties, metal compatibility, oxidation properties, electrical properties, and corrosion properties. Out of them, the corrosion property and the electrical property are one of the major challenges in EV fluid development. Because of that, we have a concern as well as the requirement of, in the concern part, the electronic systems which are getting exposed to the vapors of EV fluid are susceptible to, of course, corrosion, as well as the electric motors which are getting exposed to the liquid are also susceptible to corrosion. So there is a requirement to assess this property of EV fluid, for which we have developed a new apparatus which has, of course, the right side image is showing the plot of that, and it has the capability basically to measure the change in electrical attributes of the electrical component. After that, we can also measure the amount of corrosion based on the spectroscopic techniques, and following we can also measure the morphological analysis of the electrical components. So we have also filed a patent on that. It's pending for approvals. Considering the mechanism of this particular equipment, it has the capability to receive the signals and use those electrical signals to assess or determine the change in the electrical attributes. Followed by with these changes, it can measure the change in the physical attributes of the electrical component, and then we can also assess the extent of corrosion of the electronic components or electrical components in the equipment. The image which is showing on the back side, it's the equipment that we have developed. We have named it MAC resistometer. MAC is our brand, lubricant brand, so we have tried to combine those words with that. Moving on, I'll show you one formulation study that we have done using this equipment, in which we have used one automatic transmission fluid having the base fluid, that base oil, different base oil, right from group 2, group 3, group 4, and of group 4 having high oxidation stability. The test conditions are also mentioned at a high temperature of 150 degrees Celsius for around 72 hours. So the observation in the vapor phase was that in the group 2 and group 3 formulations, we can observe a sudden change in resistance over a period of time. And the impact of the vapor phase is largely demonstrated by the ability of the base fluid to withstand high temperature. The right image is, of course, of the electrical component, 0.5 mm thick copper plate that we have embossed on that composites. The thickness has been determined based on the typical thickness of any electrical panels that we have, electronic components. In the liquid phase, the left plot we have we can observe that the change in resistance has been determined, and on the right side there's a image obtained from the optical profilometer of this electrical wires, copper wires. The whole idea and the results outcome is that the impact of the liquid in the liquid phase is majorly demonstrated by the oxidation stability of the fluid formulations. So coming back in the last part, I'll just mention on the conclusions, what we are going to conclude out of it. With this new advancement in EV powertrains, we need or we require one corrosion protection properties of the electronic components, all both in liquid as well as vapor phase. The present apparatus that we have designed and developed is able to measure both these properties in terms of change in resistance and voltage. Amount of metal loss also we can determine using some spectroscopy technique like XRF ICPs, and the morphological study can also be done using some imaging techniques like optical profilometers. Finally, in this formulation studies, we observe that the mineral-based formulations have a higher tendency of corrosion in comparison to the synthetic formulations, both in liquid as well as in vapor phase. Thank you.
Yeah, thank you so much, Nikhil. It's a very nice presentation on measuring the corrosion resistance of EV, which is very corrosive nature. You have some found novel ways of measuring the corrosion resistance of these material. Thank you so much for finishing your presentation well within time. We'll have the questions at the end of the all 4 sessions. For the next session, I'll ask my co-chair, please.
Yeah, wonderful presentation, very comprehensive views on this. Now I invite Geeta Singh to present her paper, please.
So first of all, thank you so much for giving me the opportunity to speak today at this distinguished forum. So today I'm going to speak on salinity gradient power, which is a new and an emerging ocean technology. So how we generate electricity is we use difference in salt concentration between 2 water sources. So imagine a situation when river is about to meet the ocean. So every time the river is meeting the ocean, there is a difference in salt concentration between the river water and sea water. Using that difference, we are able to generate electricity, which is available round the clock without any battery energy storage requirements. Now, how we do that is, if you see the picture on the right-hand side, this is the stack that we have designed. The stack consists of ion selective membranes. So as you can see, the yellow and the browns, these are depicting the ion selectivity part of the membranes. So one membrane will select the positive ions, the other will select the negative ions. So what happens is, when we flow the salt water and fresh water in parallel through these stacks, what happens is the salt ions wants to homogenize with the fresh water, and as a result of which the ion starts to pass through. Then these ions get selected by these ion selective membranes, and in the end we have electrodes which then select both the negatives and the positives, and we can generate electricity. Now this combination is not only possible with river meeting the ocean, but also when there is a fresh water coming out from sewage treatment projects. So a lot of municipalities have sewage treatment plants where they're throwing the treated water into the ocean. So if the ocean is close by and there is a sewage treatment plant which is treating the water, that's also a very good combination for us to generate blue energy. Now, the methodology that we use to generate electricity is called reverse electrodialysis, RED in short. And we can generate round-the-clock renewable energy. The global potential estimated for this technology is about 3.2 terawatt. Now, this analysis has been done by IRENA, which has looked at the theoretical and technical potential, and the theoretical potential estimated for Asia alone is 1 terawatt. Now, let's also look at the picture on the right-hand side. So this depicts some of the region where this technology will work slightly more efficiently. The reason for that is high salt concentration in the sea water and warmer climate conditions. So if you notice, the area around equator is the more preferable area for us, because there is high salt concentration and warm water conditions. Both these conditions enhances the efficiency of the modules. And that's why India is one of the most preferred blue energy destinations, because India is surrounded with ocean from 3 sides. It also has warm climate conditions, and there are about 26 significant rivers flowing into the ocean. That results in massive blue energy potential. Also, important thing to mention here is for setting up a blue energy project, about 2/3 of the project cost components can already be sourced locally because it consists of pumps, pipes, switches, cables, etc. Only the 1/3 of the project cost component for the first project will be sourced from Netherlands, which is where we are currently manufacturing the stacks. But going forward, when the potential increases, we would also want to manufacture the modules in India, thereby making this probably the only renewable energy project which will have 100% made in India components. Now let's look at some of the rivers of India and let's try to analyze the potential of blue energy from this. Now this is an excerpt from Wikipedia which only lists about 12 of the rivers, Indian rivers, which are flowing into the ocean. Important thing to note here is the annual average discharge, which is cubic meter per second into the ocean. Now, if you see the total in the end, the total annual average discharge is coming to be about 67,000 cubic meter per second. This 67,000 cubic meter per second, if we base on our model, which is the 2004 model when we started working on this project, we need to harvest 1 megawatt potential using 1 cubic meter per second of seawater and fresh water. That means we have a total potential of 67 gigawatts just on the basis of these 12 rivers alone. Now, a little bit of comparative of salt gradient energy with solar, wind, and hydro. So, unlike solar and wind, we can generate round the clock, stable, reliable, and continuous power. We do not need battery energy storage to generate round the clock power. Now, the capacity utilization factor is also something very, very important to look at, because we can generate power which has the efficiency of 99%. Now, out of this 99%, we consume about 25% as aux consumption. This goes in basically pumping the water in through the stacks. So the net power output is about 75%, which is directly comparable with any coal-fired projects today. Then there are a lot of studies done on our pilot project based in Netherlands, and it has been observed that we do not cause any ecological harm, unlike any hydro projects. The gestation period is also very low as 18 months. The other most important factor to look at is that we do not require large parcels of land. So for a 100 megawatt project, it is estimated that we would roughly need about 10 to 12 acres of land, because we do not need to grow in a horizontal way, but we can grow vertically. And 2/3 of the project cost components can already be sourced locally. So blue energy's role in energy transition is, it is fully sustainable because we are not using any carbon sources. It is available round the clock throughout the year. We don't need any battery energy storage. The energy that we can generate is highly predictable because it is flowing through the stacks, so we can monitor the flow of water, and the energy can be generated on a very predictable basis. And if we are to directly feed it into a green hydrogen electrolyzer or any industry, then there are hardly any conversion losses because we are generating DC power. Now, let me take you through our pilot project, which is based in Netherlands. It's the world's first blue energy pilot project, which was inaugurated by the King of Netherlands, His Royal Highness King William Alexander. We started working on this technology in 2004, and REDstack is a spin-off company from Wetsis Institute, which is an institute working in the water-related innovations. In 2005, we started deeply working onto this in the laboratories of Wetsis Institute. And in 2014, we commissioned our pilot project, which is running successfully for last over 10 years. Now, what we have done in this pilot project is we started with a very small scale project and we have upscaled it to 2,000 times. And now with that, we feel we are ready to go into a megawatt scale. So recently, we have also been awarded various awards at Aquatech Innovation Award, and especially Blue Energy was awarded as Innovation Not to Market Yet. We were also given Dutch National Icon Award. Now, this award is a very prestigious award because it's given only once in 3 years, and it's given to a company which is not only solving the societal problem but is also good for the business. Some of the observations from the Blue Energy pilot project. So it has been generating power which is available round the clock throughout the year. We have not noticed any degradation in any of the projects, meaning our projects are running at the same levels as at the time of commissioning. Also, the capacity utilization factor is highest compared to any other renewable energy source. There are various studies done at our pilot project from institutes like Deltares and NEOS, and they have concluded that we are not causing any ecological harm to any of the ecology around us. The O&M cost today is very comparable with any other water treatment project. So far, we have invested already about 50 million euros into bringing this project from 2004 days to 2024. We are investing further 11 million euros to upscale our pilot project to 16 times and also industrialize the stack manufacturing facility. And with that, we feel we are ready to go into the megawatt scale and the commercialization of blue energy. Recently, the European Parliament has amended their directive to include osmotic energy, which is also one of the names given to salt gradient power, as the renewable energy source. And that is what we want to also do in India, to include this in renewable energy source. Thank you.
Thank you, Geeta, for this very novel way of storing, generating electric power. Till now, we had heard about the ocean energy through waves. Now it is a different novel concept. Thank you so much. And for the next presentation, I'll ask my co-chair.
Yeah, very good presentation. Upcoming technology. Very happy to see it is crossing TRL 7. Look forward for the future. It seems to be very clean energy, and the best benefit, as I have noticed, is it doesn't require round-the-clock power. And we hope that very soon this technology will be commercialized at a very high scale, and at a global scale the benefits can be achieved. Yeah, thank you very much for your presentation. Now I invite our next speaker, Dr. Deepak Kumar Singh, to come on the stage, please.
Hello everyone. First of all, I would like to thank IEW for giving me this golden opportunity to present our work in front of the audience, sharing the same vision. So today, my topic of presentation is the simulation and sensitivity analysis of free piston linear motor generator for electric power generation fueled by low carbon fuel. This is the layout of my presentation, which I am going to follow throughout my presentation. I will start with the introduction, literature review, then system architecture of FPLMG, that is free piston linear motor generator, then the simulation approach which we have opted, real discussion, and at last I will conclude with conclusion. So our MD has given a clear vision that we have to become a carbon neutral company by 2025, and we have to shift our attention to the clean energy. So by betting on this path and the thing, we are going to this method only and look for the Reliance New Energy initiative. So right now, before landing to the main topic, I would like to tell what is the motivation that drives us to do this work. So as we know that for digital telecommunication mast, we have a backup of genset, that is GL genset. But there are a lot of challenges that comes with that digital genset. First is the high capex. We have a high operational expenditures. We have also have a problem of frequent maintenance issues, and not less that is a diesel theft also we have that problem. And what are the effect of that? The effect is that the operating costs get elevated, and it also hinders the overall reliability. So now what we can do? So to overcome all this formulated problem, we evaluated multiple technology options which can work on low carbon alternative fuels. So basically we have evaluated 4 technology option. That is, first is conventional diesel generators genset. Second is a diesel generator sets that is retrofitted with part fitted to run on methanol. Then free piston linear motor generator. And then also we have evaluated a technology with opposed piston engine. So before doing to any research, because we have to do what has been happened till now. So what is the literature review which is presently available? So we have evaluated the multiple sectors of the technology. That first is the conventional diesel generator set, in which we found that there is a 27% of net fuel to electrical efficiency, and also 4-stroke multi-cylinder conventional engine. They are naturally aspirated and they follows the protocol of CPCB2 compliant. Second is the diesel engine that is modified to SI engine that is fueled with the low carbon alcoholic fuel. So what are the characteristics of that engine is that they have low capex, higher efficiency, low alcoholic fuel, but they're suitable for the type of diesel engine. And then we evaluated the concept of free piston linear motor generator. This brings us the quality of the flex fuel option. We can work on any type of fuel because it works on the variable compression ratio. We can change the compression ratio at any time of the working position. It also gives the lower friction and no crankshaft. So we don't have a crankshaft issue to convert that energy also. And there are a lot of different companies they are working on this sector, are the Liberty in Mainspring like that. And then we have a opposed piston engine. This is the best technology in terms of packaging. It is an improved combustion efficiency, reduced friction losses, and improved pumping losses. But also the thing is that the companies which are working on this opposed piston engine are Achetas like. Now, after doing with the literature survey of the technology, we went to the combustion strategy. So there are a lot of different combustion strategy for this. Like we can go for the SI engine, we can go for the CI engine, we can even go for the HCCI engine or go for the RCCI engine. Every engine have its own characteristic. Like that in the SI engine, it's a fuel with a need low alcoholic fuel, offer the potential for a low cost renewable fuel by the virtue of its less complex PFI fuel system. But in the case of CI engine, it can able to efficient use of low alcoholic fuel with NOx. In the case of SCCI engine, it gives the potential for the operation with higher efficiency and lower NOx and soot emissions. RCCI engine basically it can valorize the low alcoholic fuel by reactive stratification of technique. Now, as we are doing this technology, we are doing on the working on the software. So first of all, we have to validate what we have done. So for the model validation, we have taken for comparison of 2 different engines. First is that Aziel engine, which is a displacement of 76.3 liter, and there are configuration of V16 engine, and the fuel type is diesel. And second is a engine characteristics, that is a low quality of engine, like the 2 liter displacement only, and configuration is a 4 type of engine. And we saw that and we have distributed the type of energy. In the case of higher order of higher displacement of engine, we saw that the loss of exhaust, it went to higher, but as compared to diesel, we saw that it went to the 38.69%. So basically, we did the 0D calculation to distribute the different portion of energy. Now, how we proceed with the simulation? So before proceeding with the simulation, the first thing is that our objective is that we have to valorize the low alcoholic fuel using the technique of FPLMG. Now, to do that, we have to go do the literature survey. We have to do the literature review. After doing the literature survey, we came out to that, yes, this is the technology and this is the work which has been done till now. We went to for the 0D model development for the geometry estimation, everything. And then after that, we went for the low analysis for the FPMG for the 0D model front and the compression issue. And then after this, we have the development of a 1D model for the physics based, so that it can be do for the analysis. And at last, we can do for all the combustion characteristics of that. And finally, we can go for the sensitivity analysis to do the parametric analysis for that. Now, what is the system architecture for the FLMG? How it works? So basically, in the system, FLMG, we have 5 different components. Like first, we have a air bearing, we have a ports, we have a piston, magnet, and coils. So basically, these all components, as we have these pistons, they can be directly connected so that we can transfer the mechanical energy directly to the electrical energy without any crankshaft. So it gives us a lot of different facility for that. So, and also the pistons, we have that coils that is rolled over the piston. When they moves around the combination of the magnet, they automatically they get into displacement conversation, and then that can be utilized for generation of electricity. So basically, without any crankshaft, we can able to generate electricity, and also we can change the same piston can be act as the actuator also. It can act for a generator also. So both things can be attached here. For everything, like for if we are doing for the losses, so we have some combustion losses also, and we have a friction losses also. But for the technology option to do for this analysis, if we are going for the wireless piston links or HCCI engine, it case we will give the higher complexity, and also the efficiency advantages will be less in that case. But for the case of technology option to improve the bounce and bearing losses that consume one of the greater part of losses in this system, that can be also be optimized. So basically, what I mean to say is that in order to develop this type of technology, we have to optimize everything. Like we have to optimize the port optimization also. We have to do so that we can know at what point we have to bring the fuel in, and what point we have to take the fuel out from the chamber. So basically, based on that, then one more thing, that it doesn't need that only two piston. We can go for the single piston also, and we can go for the multiple piston also. So based on that effect, we can do anything with this type of technology, where we can able to use different type of fuel by just consuming this energy, and also for the thermal bearing coating also. So this is the system architecture of the FLMG technique. Now, after we evaluated this technology of FPLMG, so we have done the biography of that, how the energy get distributed into different sectors of that. Like we have a combustion losses of, in this energy we have fuel energy of 20.9, and then we have combustion losses of 46.3%. That is the IIT indicate thermal efficiency of this engine. And but at last we are getting the brake thermal efficiency of 43.4%. And all in the case of that, net electrical efficiency we are getting as 37.4%. So based on the simulation result, we found that the net electrical efficiency of the free piston linear motor generator is approximately 37%, which is higher than our diesel genset which we are using. And also FVLMG has the capability to operate at a variable compression ratio, and the ability to operate at the variable compression ratio, it allows to efficiently generate power using different fuels and fuel blends. And this makes it also an ideal choice for the low carbon available fuel, and even the more carbon fuel for this analysis. Now, what are our path to get to for the tower application, that is fueled with the LAF? So first thing, we have evaluated our current technology of diesel genset, where we found suppose the efficiency as a D%, in which we have a 1500 cc engine and 4-stroke of NA engine. And then if after downtime of 3 months, we can enhance the efficiency by 3% with respect to diesel if we are using the post piston engine, which is the rotary generator with and fueled by a low alcoholic fuel. In that engine, if we can go for a lower case of engine like about 236 cc of engine and 4-stroke NA, but this efficiency can increase more by 7% if we are going for a higher capacity of engine like 400 cc displacement or supercharged. It's going to be a opposed piston architecture, and the heat loss could be very lower. It can also improve the combustion, and it is also having a very less emission also. And the CPCB it can compile this CPCB4 without after treatment also, we can do that. So this is the power of this type of techniques. If we are going to utilize, we can go to shift to this engine also. Now at last, if we are going for the free piston engine with linear generator LAF, the efficiency get increased to 10% with respect to diesel. And what are the characteristics, what are the benefits we are getting with this type of engine is that we will have a variable compression ratio, that is flexible potential. We can go for the improved combustion with 2-stroke, and thus it will give a better energy density as compared to that diesel engine. And also we will having a lower friction due to air bearing and no current shaft. So lower vibration and noise due to bounce chamber can also be came into effect if we are taking for this type of technology, in which we do not need crankshaft to transfer our mechanical power to a rotary power. We can directly go for the mechanical to the electrical power. Now, coming to the conclusion section, so different technique like diesel engine retrofitted to SI engine, FVLMG, yeah, a post piston engine were explored that can be fueled with low alcoholic fuel and that can be efficiently also. And also, it can also be concluded that FVLMG is the best solution to boost energy power and reduce harmful emission. And FVLMG works on the variable combustion ratio that can valorize and can be a flexible also. And a post piston engine is the optimal solution for low alcoholic fuel in terms of packaging, and which can reduce this efficiency also. And at last, the free piston injector motor engine, we got it as the highest of fuel to electrical efficiency compared to all existing technology. So these are the references which I have taken for the analysis, and I would also like to thank Mr. Trideep, Mr. Somsekhar, Hari Ganesh, and Arun Venkateshwar for internal help for this doing this all this project and everything. Thank you.
Well, thank you so much, Dr. Deepak. Very engaging presentation on utilization of low alcoholic fuel and the modification in SI engines, eliminating the frictional losses. So, would like to say anything on this? So, this is the end of the session, and we thank you to all the speakers. You are finishing your presentations well in time, and let's say goodbye to all. Yeah.